Hello, everyone. Welcome to MedX's Sprint 2 deliverable. My team decided to create the MedX AI product, which is a common thorax disease detector. In today's presentation, we will cover a recap of Sprint 1, which includes member names, roles and responsibilities, improvements, project description, team working agreement, and personas, followed by the project overview, which will cover the MVP, languages and tools, algorithms, and diagrams. Next, we will look at the product backlog and sprint backlog, including the user stories, acceptance criteria, sprint 2 stories, test cases, and story completion. Then we will move on to the team metrics, including team velocity, burn down charts, and the retrospectives. Lastly, the product, which we have Sprint 3 stories, application screenshots, API, and a live application demo. We have 8 members on our team. We continue to think of ourselves as self-organizing and cross-functioning. And to begin, we have Ronaldo.S, which is a Scrum Master and developer, myself, Marla Capistron, as team leader and database administrator, Filippo Zaloco as a developer. And as you can see or notice, there are yellow stars, and these stars mean that there were improvements made to the slides. We also have a Christopher Ospina as a developer, Anthony Munoz as a quality insurance tester and developer, Liana Machado as a developer as well, Raul Nayanagali as a developer, and then Preethi Raimanya as the designer and developer. As previously mentioned, there have been a few changes made to some slides due to Professor Wong's generous feedback to enhance our project. First, we have the team roles and responsibilities were updated to reflect developer roles. This clarified that the individual was not just doing that job, but took on more responsibilities. Next, we included the project description page, which we will see in a few minutes. Then we changed the product design journey to the product discovery to clarify how the project's design was collaboratively discovered. After that, we show how we simplified the MVP design. And lastly, we added explanations for the technologies and algorithms. And this is all indicated with a star. The problem today is that currently X-ray machines are widely available. However, clinical X-ray images can be challenging to read and diagnose. Furthermore, X-rays are not a priority for radiologists as they tend to focus more on CT images and MRIs. CT scans are both harmful and expensive, in addition to time-consuming. And so our project, the Common Thorax Disease Detector, which is a web app that has a highly trained deep learning model, can classify these X-ray images, reducing the need for a radiologist to examine them. It is intended for medical professionals and patients who upload X-ray chest images. And it uses a deep neural network model that will detect common health issues rather than having to wait for a radiologist to examine the X-ray images that are not a priority to them. Our application will reduce the time it takes for the patient to receive their diagnosis using AI. Some of the benefits from utilizing our application are a faster physician response rate. It's also cost-effective, reducing the need to hire more professionals. The use of AI reduces human error and efforts, and it also partially automates the chest X-ray review process, and it improves physician workflow. The team working agreement was created during Sprint 1 to lay out expectations in order for the team to have a smooth and successful completion of the project. We commit to being transparent, accountable, honest, being proactive, and taking initiatives in tasks where a member is capable. And above all else, we prioritize the success of the project. This document outlines the team's communication, participation, meetings, respect, which ensures the success of this project and each of its members. And now I'll hand it over to Anthony.
Thank you. So, as a patient, you rely on medical professionals. You get checkups, health advice, and recommendations for procedures such as x-rays when they're deemed necessary. However, people are busy with their daily lives, trying to balance work and family, so it's hard to schedule appointments, not to mention follow-up visits that may be required as well. The time taken to get results, depending on the procedure, can be a challenge in itself because it might take a long time. So you manage to eventually make your follow-up, you sit down with your doctor, and you can still come out of that consultation with some questions. So using our common thorax disease detector, patients will be able to get the results faster. They could view results on a website that's easy to navigate. And a patient could see a doctor's comments about the result right away, allowing a patient to understand what their results are without scheduling a follow-up for another in-person visit. Next slide. You. So healthcare facilities are currently facing unemployment and they're in need of modern equipment. Due to issues such as budget cuts and the rising costs of medical school and the debt that comes with it, not many people want to specialize in radiology and wait until they're 30 to start their careers. This leads to clinics suffering from a lack of applicants. In addition, the current number of radiologists is not enough to train recent medical school graduates and accommodate the growing volume of patients. These challenges are the root cause of burnout and long shifts, which leads radiologists to think about whether they want to stay in the profession. Lastly, the nature of the job requires radiologists to work with sensitive cases such as cancer, which directly impacts their ability to tend to all patients equally. So we found that our common thorax disease detector can alleviate the workload by automating the detection of known chest conditions. This would allow radiologists to concentrate on their more complicated cases, improving their overall workflow. Next slide, please. Doctors have a large volume of patients with limited time for consultations. They sit down with their patient, they explain to the patient what the diagnosis is, but patients can leave with questions that they could possibly look for answers online, which could lead to greater confusion and anxiety about a diagnosis. So using our common thorax disease detector allows for a doctor to communicate with the patient by leaving comments about the diagnosis that would explain the results clearly. This would also help build a strong relationship between the patient and doctor as well. Next slide, please. So onto product discovery. We started our product design by collecting ideas from each of our teammates. We gathered the designs as shown on the screen, and we picked the parts from each design that we liked. And then we discussed stuff such as color palette, and we agreed on a final product design. Next slide. So this is what our final product would look like. We'll have features such as being able to upload the x-ray, get the results that come with a description of what it is, along with the doctor's comments underneath. You could also see the x-ray ID. There's a progress bar that lets you know when the image has been fully reviewed, and an option to download the report for your own personal records. Next slide. And as you can see, this is our current MVP design. We used Figma to create and visualize it. As you can see on the right side photo, there's an option to browse and pick a file, or you can drag and drop onto an X-ray image. And on the left side photo, you could see that after the image after you've uploaded the X-ray, this is the result that we expected from our MVP, and we achieved this, which will be shown later in the presentation. Thank you. And now I'm going to pass it on to Rahul.
Hey, thank you. So good afternoon, everybody. Today we are going to dive into the cutting edge technologies powering our MedX. So at the core of this application lies a powerful combination of programming languages frameworks, algorithms, database tools, and which are all working together seamlessly to deliver accurate and efficient medical diagnosis. So before we delve into the specifics, let's take a moment to highlight the technologies upon which Medex is built. So first of all, programming languages. These are the building blocks that enable us to create dynamic and responsive user interfaces as well as robust backend systems, right? And at the heart of Medex lies a sophisticated deep learning algorithm that leverages the power of AI to analyze medical images with accuracy. And next, databases, right? So for secure and efficient data storage, which is crucial for our application, and Firebase enables us to manage and retrieve patient information and medical records seamlessly. So next, tools. So to streamline our development process and ensure seamless collaboration, we have selected a suite of powerful tools that enhances our productivity and workflow. So next slide. Let's explore the programming language and frameworks that power Medex. So we have chosen powerful combination of HTML, CSS, JavaScript, React, Node, Tailwind. So these front-end stack which being leveraged by Medex for the dynamic user interfaces. And next slide. So we're using Python's micro framework, which is Flask. So to render the chest X-ray findings on the UI by calling the trained model, which is being created by the deep learning model, which we discussed earlier. Next, we are going to database. So we have integrated Firebase for secure image storage and API access. So here we are storing the uploaded images and which Firebase in turn provides an endpoint URL, which we can use to call the API. Next, moving on to tools. For efficient collaboration and streamlined workflows, which are essential for any project. So therefore, we have carefully selected a bunch of tools to optimize the development process. So Figma facilitates design collaboration, enabling seamless contributions to the overall development process. VS Code serves our primary code editor, which is providing a good environment for coding tasks. GitHub is a remote version control where our all collaborative development tasks are done. And Docker simplifies development processes on various platforms, so we don't have to worry about uh, dependency, which gives us platform independency, right? So in Insomnia, which is a tool which we use for testing our APIs so that we have a proper responses before deploying onto our front end app, right? So moving on to our algorithms, right? So let's dive deeper into the details of our algorithm. So our model integrates various layers, each with specific role. And we have convolution layers, which are like filters that help us detect important patterns in the X-ray images. And these patterns could signify various abnormalities or conditions. We've also incorporated batch normalization, which ensures stability uh, and accelerates the training process. And dropout is another essential component, strategically dropping out some neurons during training to prevent the model from becoming too reliant on specific features, thus which helps in reducing overfitting. And regularization plays a crucial role in controlling the complexity of a model. It uh, it helps prevent it from becoming too intricate, which could lead to poor generalization on unseen data. That is the training data which we'll be testing, right? Sorry, testing data which model doesn't know. To optimize the training process, we have utilized ADAM algorithm. ADAM, which is an adaptive learning rate optimization algorithm that adjusts the learning rates for each parameter individually, resulting in a faster convergence and better performance. Now, this makes a model even more robust in extensive training data, which has been exposed to. So we trained our model using data consists of 15,000 chest X-ray images. This vast amount of data ensures that our model has learned diverse patterns and can provide reliable diagnostic insights. So with this combination of technologies, Medex aims to enhance medical diagnosis, offering accurate and efficient solutions to our patient care. Thank you. I'm handing over to Preet.
Thank you, Rahul, for the introduction to technologies. Now we'll understand how we brought this technology into actions through several diagrams that we have created. The first comes the context diagram, which explains the basic context of how our application be going to be used. There are three main personas, which was earlier explained by Anthony. There are doctor, patient, and radiologist, where doctors can upload the image and receive the report directly. Also, in the meantime, parallelly, patients also can do the same by uploading their X-ray image received by the hospital and receive the report right through the MedXR. And also, on the other hand, radiologists can create a X-ray report and forward it to the doctor. That will make the process easier. This whole magic is done within the MedXR that will be explained later by Ronaldo. Next, please. Now that we understood the context of how our application is working, let's understand our database. So there are four main tables. One is patient table, medical professional table, X-ray table, and the last one is hospital table. Patient table is where all the information related to patients, such as their first name, email address, phone number, etc., would be stored. The next is medical professional table, where the storage of information such as the profession of the doctor, such as radiologist or a doctor, would be involved. And the next would be hospital, where hospital contains their address, email, and phone number. All these three tables would be directly connected to the X-ray table, where all the information of the report will be provided. Next, please. Now we understood the a basic of our database. Let's understand how they are interrelated through entity relationship diagrams. So as we know, there are four main entities. One is medical professional, hospital, X-ray, and patients. So these four entities are tied within themselves by these relationships. The medical professional works at which hospital, and hospital has the property, the X-ray is the property of an hospital, which all is directly connected to patients. For the patient to view the X-ray, it has this flow of data through our medics. The next would be architecture diagram. Next, please. So yeah, here we are going to understand how our architecture is based on our technologies. So first comes the front end part, where there is a user interface where all of these personas will be acting first. The user would be uploading the data, and which is an image will go directly into our backend. And also there would be a flow of data towards servers such as Flash server, which is used to fetch and push the data into our neural network model. This all will also be synchronized to our backend. And finally, the report will be back available to the user. This whole application to be used everywhere easily, we have Dockerized it into a Docker container. Next, please. Understanding the architecture, now we see how the flow of data is going. So first, the user will upload the X-ray, and then after, the web app will use the Firebase API to send it to our Firebase storage. The Firebase storage will then generate the X-ray document with image URL and X-ray ID, which will then be fetched by the web app again. This URL will be further pushed to our MedXR tool, where MedXR will download the image locally into the server environment and start analyzing the image. Furthermore, the image would be sent with the result into a Firebase storage, and the updated generated report would be further pushed back to the user, and user can view them. After understanding this, let's see how the state of the app is working. The next diagram would be the state diagram. So this actions can be done after the user is logged in. So first, the image will be uploaded, and the state of the image would be in pending. Next, the program will decide whether the image is correct or not, and that will be either the state has been accepted or rejected. Once the image has been accepted, it is processed through MedXR and then classified and reviewed by the doctor. And last would be a result. If the X-ray is rejected, if the file type is wrong, or we cannot find any of the abnormalities, it will show no finding. This is the state of state of our web app. Thank you. That's it from my side, and I'll pass it to Christopher now.
Thank you, Preet. And I would like to now present our user stories. So, as previously mentioned with our personas, radiologists, doctors, and patients, we need to use the app for different reasons. Let's say a doctor wants to easily upload X-ray images so that other doctors and their patients have access to those images. So, in order to achieve that, we broke the task down into what we could achieve in different sprints. For example, the easiest one could be achieved right now. And for harder ones, like patients wanting to view whether a doctor has reviewed X-ray results so they could be more confident, we were working on that for the next sprint. Next slide, please. And for a sprint after, we're then going to tackle some harder tasks, like patients have access to all the X-ray report history so they can track their health issues. Since that's harder to accomplish, we're probably gonna have that ready in 2 sprints. Next slide. Doctors also want to be notified once there's a change to the report. And that's also hard to achieve right now, but we're working on that in 2 sprints. But for next sprint, we're working on patients being able to browse a specific report so they could quickly locate information. Next. And then we have certain security functions like logging in, logging out, setting your email, date of birth, password. And that we're going to work on in 2 sprints to ensure that the apps are secure and the users have access to their own private personal information. Next.
Based on each user story, we described the acceptance criteria, which represents the conditions that must be satisfied for the user story or feature to be accepted. This was done using the structure of being given a prediction when something happens, and then there is a result. For the sprint, if a radiologist, doctor, or patient wants to upload an X-ray image through the image upload feature, when they open the MedX AI web app, click on the upload button and select an image file or drag and drop the image. Then the application will store the image for processing. In this scenario, the criteria our web app must satisfy is being able to store an image file for processing. Next slide, please. Another acceptance criteria the team has met for the sprint is for the web app to provide a diagnosis or finding for the X-ray provided through the MedXO feature using AI. When a radiologist or doctor uploads an X-ray image, then the application will classify and provide a quick diagnosis, and then they will be able to access the results. For Sprint 3, we will be working on the doctor note feature, which will provide a message section for each report to allow doctors to post comments for the patient to see. This would be a form of communication between the doctor and the patient for any extra information that would be need to be mentioned. Next slide. Another criteria we will need to meet in the next sprint is a reviewed status feature, where a patient can view a status file reporting if a doctor has verified their X-ray result when they click on any of their reports. Also, the criteria of the web app providing a text description of the X-ray finding classified is in a selected report will be satisfied during sprint 4. Next, please. Some other notable criteria to be met in the following sprints are for MedX AI to be able to download report files to the user's local system, and for users to have a history of past reports available, which are stored on the cloud. When the user logs into MedX AI, then a dashboard page will be displayed with the most recent X-ray results. Along with the dashboard being the first page, a notification feature will be added during sprint 4 with the criteria of alerting the user of a change made to their report. And then in the next slide, in sprint 3, the web app is expected to store reports using an X-ray ID and patient name for the search feature to quickly locate specified reports. And then next. In the last sprint, users will have profiles where the criteria for MedX AI to store user credentials so that users can create their own account to securely access patient information. Along with the profile feature, the web app is expected to have a login and logout system for radiologists, doctors, and patients. When opening the app, the user is then prompted to log into their account and with their credentials and click the logout button to end their session. With the login and logout system, MedX AI is expected to create and store accounts where a medical or MedX ID is used for physicians and personal email is used for patient accounts. And then the next one, lastly, the team expects to meet the profile criteria, which includes allowing patients to update profile information and store the changes in the database when a user goes to their profile and clicks the edit button. Profile information includes their name, address, and phone number. All the conditions described must be satisfied for that user story or feature to be accepted and considered done. And now I'll be handing this off to Mala.
Thank you, Leanna. So as we created a working application, we created some test cases to ensure that our application was running as intended. We aligned these test cases to our user stories, which we have indicated with user IDs, as well as the feature being tested. So you could see the user stories associated with the test cases on the leftmost column, and then the feature to be tested in the second column. For example, we tested the image upload feature in which we verified whether an image is accepted with an accepted image, such as PNG or JPG file type. And it was accepted by MedX, or we expected the image to be uploaded and presented, and the actual result confirmed this by uploading it to the MedX tool. This test case was passed. Another example is for the Firebase. We were testing whether there was a successful image upload. Again, we used a PNG or a JPEG file. We expected the image to be uploaded and stored in Firebase, and the actual result was that the image was uploaded and we as developers could see the image available in the cloud. And again, this test case also passed. Next, we have test cases in which we test the findings feature, in which we pass an X-ray image with a disease to MEDX through the neural network model. If the image is supported, then we expect it to have either a no finding or a finding. And if it has a finding, it will give a medical term for it. In this case, the actual result was aortic enlargement. We have passed these test cases, but it is to be noted that we do have insufficient data with our neural network model that it may be inaccurate. It may not be accurate. And now I'm going to hand it over to Ronaldo.
Thank you, Marla. Okay, hey guys. So as you can see here on the screen, we have completed all 5 stories that were set at the beginning of sprint 2. Next, next, next slide, please. Thank you. Okay. The sprint 2 stories that were completed were 5 of them, which if you sum all of the estimations, you get a total of 35. And as you can see, we have so there's 2 features that were completed for the radiologist that has an estimation of 0.1, 3 being like medium, and then 13 being like the most difficult to complete. And then as you can see, like the most difficult will be at the bottom, and then the mediums ones were at the top. We had some challenges for like, especially for the ones at the bottom, but we were able to kind of like stay on the right track. And then for future sprints, we were able to accomplish for the future features that we have established. Next, please. Okay, so our team velocity had a estimated of 35 points, which means like from the slides before that, like I was describing, the total of estimations added together came out to be 35 points. Okay, next. Okay, so this is a burn down chart. So you might ask yourself, what is a burn down chart? So this chart provides a visual representation of the progress of work remaining in a project over time. So as you can see, the x-axis, the horizontal numbers, they represents the estimated hours from the beginning to the end of the sprint, and then the y-axis represents the remaining efforts, meaning that like the total hours that were left to do for the sprint. And our goal was that the actually remaining efforts line to either meet or stay below the ideal line by the end of the sprint, indicated that the project is on track and is to be completed as planned. As you can see, there's 2 different lines. The blue one, which means the ideal remaining hours, and then the orange one, which is the actual remainder hours. So we pretty much completed all of the tasks for sprint 2. Next one, please. Okay, so since we have completed all of the story points, so we have a score of 100%. So nice job, everybody. Okay, you can move on to next. Okay, so for the project schedule, we use Jira, which, as you can see, we have divided each sprint to what the tasks are being set for that specific sprint. So like, as you can see, there's 3 different columns, 1 to do, 1 in progress, and then 1 done. So as you can see right now, there's not too many things left to do, and that's pretty good, because those are gonna be completed by the end of the sprint, so which is gonna be in 2 days or 1 day. Okay, you can go into the next one, please. Okay, so here's a picture of the project backlog. So as you can see, Jira does a phenomenal job when it comes to like project management. And here's like a better view of all of the tasks that like had been done and what is in progress, and what are the persons or the assign assignees working on. So as you can see on the right side, like you have all of the different members who are like either working on the task or have completed that task. Okay, next one, please. Okay, so here is a screenshot of the retrospective, and here like a few things that we put on what went well and what needs to be improved and the action items. And pretty much we came to agreement that there's three things that we are gonna try to improve for next sprint, which is writing down the steps as a reminder of how to display all participants gallery that's on Zoom, and set an update on what are you working on through Jira, and then asking for help when needed, which we all thought like that was something very important because um, at the end of the day, we are here to help everyone. So don't be shy to ask for questions. Okay, next. Okay, so this is the retrospective. What went well? Coming up with a solution to overcome software in incompatibility. Okay, team efficiency and enthusiasm towards achieving the goal, and getting clarification when there were doubts. What needs to be improved? Outlining tasks for each team member, sending an update whenever someone is done with the task, figuring out how to do Zoom recording so everyone is display gallery view. And then for the action items, writing down steps of how to display all participants on the screen, send an update on Jira, and asking for help when needed. Okay, next. Okay, so these are the current sprint 3 stories. As you can see, there's 7 right now, and obviously this is like not set on the stone because as we meet again for like the weekly meetings for sprint 3, we will be adding more. So but like this is like kind of like a rough view of like what sprint 3 is gonna look like for us. And obviously we already met like a few times to kind of like make sure like these were okay, and this is already set on Jira, which sprint 3 has already started, so everything is on track as of now. Okay, next. Okay, so this is the code snippet for Medexer. As you can see, there's dependencies on the top. So what Medexer does, it handles the file browsing and drag and drop feature, which means the user can drag and drop the X-ray, the chest X-ray image, and then we have the neural network um, working on the backend that analyzes the X-ray, and then it tells you what disease you have based on that X-ray. But like this is just like a little example of code snippet from the Medexer. As you can see, there's libraries on the top, and then you have all of like the logic being done on the body. There's a lot of functions for like all of the different features that I just explain now. And that's pretty much from my end. And now I'll pass it on to Filippo. Thank you.
Thank you, Ronaldo. So here are a few snapshots of what the application looks like to the user. To the left, we have a screenshot of the first stage when the user boots into the application and finds a record of the previous session with the results and the scan X-ray image. To the right, we have another screenshot of the Medexer page. Obviously, it's empty as it is yet to accept an image after clicking on Browse. And these are the pages that are rendered by the front end. Next slide, please. In this screenshot, we may appreciate the fact that the user is returned a result of the scanning right after uploading the image, and this happens in 59 milliseconds. Next slide, please. We also have a screenshot that proves that the function of uploading returns an error in case a different format of the image was uploaded, such as PDF or a non-PNG or JPEG file. Next slide, please. We chose Firebase over MongoDB because Firebase cloud services come with Google APIs, which allow our team to use the image URLs with a vast array of cloud technologies and services provided by Google and other providers. With the Madaxer page, we import the APIs to access Firebase storage service like ref, get download URL, and upload bytes. We use ref to create a reference from the storage service. We use get download URL to copy the Google generated API embedded inside the uploaded images URLs for later use. And finally, upload bytes is the function that generates the URL of the uploaded image by converting the JavaScript object into bytes. Next slide, please. Flask is our runtime environment and library for the backend. It is very similar to Node.js, but it is engineered with Python in mind. With Flask, we use the course class, which allows for direct exposure of the backend service, localhost HTTP 5001 predict, in particular the port of access to the neural network, without using middleware like proxy. And Flask gives ease of use and customization to backend services. Essentially makes backend development very easy. Next slide, please. This is a screenshot of a Docker container running the Flask environment and instances of the neural network. Dockerizing the backend allowed our team to receive consistent test results on our machines because the app's dependencies are executed in a virtual environment based on a Linux kernel that encapsulates the Flask runtime environment for the Python executables. As you can see from the container's terminal view, the average response time for the backend API responses is 59 milliseconds, a considerable drop from 121 milliseconds experienced in the Jupyter notebook in which we tested the neural network. Next slide, please. Perhaps the greatest benefit of Dockerizing both the front end and back end is booting into the applications in seconds after clicking on the container's ports instead of executing Docker comments in our terminals. Next slide. Here is a link to our live application demo.
Today, the MEDX team will present a live demo of the MEDX AI application. The Common Thorax Disease Detector is a web app that has a highly trained deep learning model that classifies X-ray images. Let's begin. The first page the user lands on when utilizing the application is the dashboard. This is where the last session of the report can be viewed. As you can see, the report includes the findings, date, and a doctor's comment. The next step after our dashboard is the MedXer tool. This allows the user to upload an X-ray image by dragging and dropping an image onto the MedXer tool. Or you can click on the Browse button to select the image. It also restricts the user from uploading incompatible images. Once the image has been selected, the user submits the image by clicking on the Submit button. Soon after, they will see the loading screen, which indicates the image is being analyzed by the neural network model. After the neural network model has analyzed the image, the user will be able to see the results. If the neural network model does not find an anomaly, then it will show no findings. If the neural network model finds an anomaly related to a common thorax disease, then it will be shown in the results. This application uses React for the user interface, Flask for the AI, and TensorFlow libraries to analyze and classify the chest X-ray images. To build this current version of the MVP, it took our team 2 sprints. We first imagined what the application would look like using Figma, a collaborative design tool. Then we began coding it in Visual Studio Code. Later on, we will be adding more features in the next sprint. This concludes the demo for the Common Thorax Disease Detector. I hope you find this application valuable. Thank you.
The following next steps are the points of development of our team. We're going to improve the accuracy of the neural network model using feature learning. Next, we're going to use structure printable and loadable report features that comes with React. We're going to be able to display a doctor's comment on a page of the application. And last but not least, we're going to add a report history and a search report feature inside the application for better use of the application on the end of the end user. Here is a link to our updated wiki page at our GitHub repository. Thank you for listening.